Okay, so how do we decompose a fraction? Actually, what we're going to try to do is a pre-calc little exercise, and then we're going to try to learn how to do a brand new kind of integral. So this is going to be another trick for integration. So what this is saying is, how would you rewrite this so that it was something over, oh no, not this again. I need this to work. Give me 1 second. Turn on smarting. There we go. Hopefully it works. How would you write this as something over x plus 3 added to something over x minus 2? We know that that's what this is, right? The factorization for x squared plus x minus 6 is x plus 3 times x minus 2, right? So we know that somehow there must be two fractions that can be added together to form 2x plus 16 over x squared plus x minus 6. But what are the numerators of these two fractions? So this is kind of like saying, I know there's two fractions I can add to get 7/15. What are they? How many thirds and how many fifths must be added to give me, 7/15? It's kind of like a reverse fraction addition question. Okay? So you actually know how I did this last year. And the a and the b are very specific numbers. There's only one value of a and one value of b that would ever make this come out to be 2x plus 16 when combined. So since I don't know what a and b are, I'm just going to recombine these with my a and b right in it. So you're just going to multiply this up to here and this up to here and group it back together again. So now we're right back where we started from. But the top looks like this. ax minus 2a plus bx plus 3b. Okay? Now we're going to figure out what a and b are. You'll notice that there's an ax and a bx here. And in the original problem, a 2x. See that? This means that ax plus bx must be 2x. It's only logical. So I'm going to assume that ax plus bx is 2x, or you could say a plus b is 2. That's the first clue. So circle that. Well, the original fraction has a 2x on top, right? My new fraction has an ax plus bx on top. So it must be balanced here, and ax plus bx must be 2x somehow, see? In other words, a plus b must be 2. Yes?
I don't get how you jumped from the a over x plus 3 plus b over x minus 2 to the next thing.
Oh, I just did a common denominator. So you just multiply the denominators together.
Oh, okay.
And you multiply the top left with the bottom right, with the top right with the bottom left. It's just LCD. It's combining two fractions. I just do it with arrows, it's faster. Okay, so you'll notice we have a plus b is 2. That's not the only clue. We can also see that, if you look right here, there's a minus 2a there, plus a 3b there, see? These are your non-x terms. And there's a 16 right there. So we believe that the minus 2a plus 3b must represent 16. It has to be true. Otherwise, these fractions have changed, and that wasn't the intention. I was just rewriting them. So what we need to do now is figure out what a and b are. It's just a little system of two equations. So you could just take this first equation and double it, add it to this one, and you get like 5b equals 20, and b is 4. Okay? So I trust you can solve this. You would just solve this to get b is 4, and a is what? -2. Okay, so these are the only two values of a and b that would even make this true. So what I'm saying is the partial fraction decomposition for this original problem is officially, here's my answer, I'm going to write it right under the question. It's -2 over x plus 3 plus 4 over x minus 2. These are the two magic proper fractions that can be added together to form 2x plus 16 over x squared plus x minus 6. So you might say, why in the world are you doing this, Mrs. Shore? Well, listen, this right here, my original fraction, is very difficult to integrate, okay? But this version of it is very easy to integrate, as you'll see in a minute, okay? So we're learning to rewrite fractions so we can integrate them quickly. Let's go to the next one. We have 3 over x squared minus 9. So we would assume that that's like a over x plus 3 plus b over x minus 3, right? Because the factorization for x squared minus 9 is x plus 3 and x minus 3. Regrouping it would give me ax minus 3a plus bx plus 3b. And now we're right back to where we started from. Comparing the tops of the original and my updated one, I can see that ax plus bx has to be 0x. I say 0x because look at the original problem. There is no x in the top. See that? It's as if there's like a 0x on the top of the original problem. Okay, so I believe that ax plus bx is 0x. In other words, a plus b is 0. And I also see some non-x stuff here. Let's do that in green again. So that's this minus 3a and this plus 3b. That must represent this 3 here. Okay, so I have minus 3a plus 3b equals 3. Or you could simply say b minus a is 1 if you divide by 3. If you solve the system, a plus b is 0 and b minus a is 1, you get, what do you get?
1/2, or b equals 1/2.
B is a half,
A equals
a is a negative half. You're right. B is a half, a is a negative half if you solve that little system. Okay? I don't have time to solve it. I assume you know how to solve a system of two equations. Okay, let's take those now and go back and write our PFD. That's our partial fraction decomposition. Okay, so we have negative 1/2 over x plus 3 plus positive 1/2 over x minus 3. Now you might say, Mr. Shore, why don't you move that little 2 down to the bottom? Actually, I'm not interested in that. I want my denominators to be extremely simple. I do not want a 2x plus 6 on the bottom here, so I suggest you leave the little fraction on top. The plan is actually to integrate, okay? So let's take a look at these next two problems. You'll notice these are the same two fractions. Well, the first one is anyway. The second one is the same fraction in disguise. I'll show you in a minute. Okay, so you guys have the PFDs, right, from examples 1 and 2? I might need you to quote them to me in a minute. Let me clear my ink here. Okay, so now we're on to doing integration problems. We're in calculus again. And let's say we run into a problem like this one. How in the world are you going to integrate this thing? Substitution doesn't seem to work. Parts may be too complicated. What are we going to do? We're going to use partial fraction decomposition. We already broke this fraction down. What was it again? It was something over x plus 3.
-2.
Thank you. And this was a 4, wasn't it? Okay, see, this is not hard to integrate at all. Let me show you why it's so easy to integrate. First of all, you could just split up into two integrals. The first one, and you can even take the negative 2 out, is negative 2 times 1 over x plus 3 dx. And the second integral, pull the 4 out, is just 1 over x minus 2 dx. Those are easy to integrate. The first one is simply negative 2 times ln of x plus 3. And the second one is 4 times ln of absolute value x minus 2. And don't forget your plus c. See? So that was actually not hard to integrate. It's hard to see how to integrate it, right? That's often the case. Integration is not that hard. It's getting it written in a familiar and friendly way so that you can add your powers or do your element or octane or whatever. Okay? So that's a brand new Q&A style question. Let's go on to the second one. That second one, you'll notice this is very, very important. Did you notice that the top and bottom have the same degree? Maybe you didn't notice it. But see the same degree? Does anyone remember what we call fractions that have the same degree, top and bottom? Improper, that's right. It doesn't mean that they're like, doing something wrong, wearing the wrong clothes to the party or whatever. It just means that it's not truly fractional, right? It's like saying 5 over 5. Is that a fraction? Not really. 6 over 5 is certainly not a fraction. So when the top and bottom have matching degrees like that, you're dealing with an improper fraction. And if that's the case, we need to first make it proper in order to get the ball rolling. So what I'm going to do is actually just do a long division real quick. So I'm going to go, what is x squared minus 9 divided into x squared minus 6, see? And if you want to put placeholder in like a 0x, you can, but I don't think we need it here. How many times does x squared go into x squared? Once. Multiplying, we get x squared minus 9. In long division, we subtract. What does this give me? What's negative 6 minus negative 9? It's positive 3, isn't it? Negative 6 minus negative 9. Okay, so we get plus 3 there. That just means that we have 3 over x squared minus 9 for our remainder term. Okay, so let's just rewrite this question. Here's what I'm saying. This problem is the same question as this. 1 plus 3 over x squared minus 9. Or, since we already did the PFD for 3 over x squared minus 9, wasn't it something over x plus 3, something over x minus 3? Look back in your second example. It was negative 1/2 for A, remember? And 1/2 for B. Okay, so this is really 3 integrals, and they're going to look something like this. Ready? What's the integral of 1? X. That's our first term. Then there's going to be a minus 1/2 and an ln, absolute value x plus 3. Then there's going to be a 1/2, and then there's going to be an ln of x minus 3. And don't forget your plus c. So basically, anytime you integrate 1 over something linear, like x plus 3 or x plus 5 or something like that, then it's just simply ln of that. The only thing you have to watch out is if the derivative of your denominator is not 1, like let's say this is like 2x plus 3, you have to be a little bit more careful to put like an extra half outside. But honestly, that's not going to happen if you always factor out your coefficients. Or if you keep this little half up top, just keep your denominator as x plus 3. Don't mess with it. All right. Now, I want you to just stare at this. I'm going to write something on the board. I want you to stare at it and convince yourself that it's actually the same thing, okay? I just wrote the answer in black. I'd like you to see the answer written a slightly different way. Do you see that this is the exact same thing? Raise your hand when you see it. It's exactly the same answer. Do you see it? One of the rules of logs is, Lauren, want to explain it? Okay, so these halfers can come up here and become square roots.
And then if you subtracting is the same as dividing or something, so the x minus 3 is positive,
Right, so one of our rules of logs is to move these powers up. So this would become like a 1/2 power. In other words, the square root of absolute value x plus 3. Same thing with this half. Then you have a log minus a log, and subtraction makes fraction. So you have a 1 log to rule them all, and everything else inside it. So it might take you a couple steps to go from here to here. But why is it important for me to show you this? Because on the AP exam, sometimes they leave an answer like this, sometimes they leave an answer like this. And the difference is a couple steps of pre-calc work, and it's easy to feel discouraged when you got that and they got that. You can't find your answer. So you do need to play around with these. Maybe you can write any answers we for 6.5 both ways. You know what I mean? You can even make this like ln of e to the x, and you can lump it into here too. Like everything can collapse into one log. And you can have one log to rule everything. Okay, so just know that log answers can be written in an infinite number of ways, technically. But these are sort of the two most common ways I've seen. Okay, so this brand new technique called PFD, supposed to be reviewed from last year. It's a BC only topic. These integrals do not show up on AB, I don't believe. Hugh, did you see that at all last year? Yeah, I didn't think so. Couldn't remember it, but. Okay, so here, right here, C is a differential equation, but you solve differential equations by integrating, right? And that's ultimately what you do. So you could do both of these examples the same way. So I'll try to put together a video of the rest of this later. There's no assignment on this tonight. If there is an assignment, it'll be due after break. So have a nice day.